Okay, today we're going to be looking at some more area problems. Okay, it was pretty clear as you were going through your stuff last night, okay, that most of the problems were set up really pretty nicely for you. Most of the information that you needed was already provided for you by the problems. It was not a very frequent situation where you had to actually solve for anything other than just plugging directly into the problem that you were dealing with. Okay, and as you can probably suspect, most of the problems, if you're dealing with area, they're not going to provide you with everything that you need. You're going to have to solve one problem so you can then take that information and plug it into the area formula. And in some cases, you may have to actually solve for a couple of different things before you can plug in. Okay, so let's look at some more realistic type questions today. Okay, we'll start off with this one. Find the area of the following rectangle. Let's jot it down and figure out what is going to be needed and what type of strategies we might use in order to help us find whatever might be missing. Okay, so I'll give you a moment to copy it. All right, well, obviously we know that we have a rectangle because the problem says we have a rectangle. Okay, so the first question, probably the most important question, is do we have an area formula that goes along with finding the area of a rectangle or not? Okay, yeah, absolutely, base times height. Okay, it is a parallelogram, and parallelograms are all found by base times height. Okay, so that's the goal of our problem, to figure out what base times height is. So have a look into the figure and let's ask ourselves, do we have all of the information that is needed to plug into this formula or no? No, okay. What would you want to say is missing? Yeah, well, with base or height, we don't really care which one's which, right? Okay, the key is that they're perpendicular to each other, but we're missing one or the other. Okay, so if you wanted to say that this guy 12 is your base, then absolutely, you're missing height. Okay, so what we need now is a strategy for what we can do with the problem that might allow us to figure out what our missing height would be. What do you think? Yeah, Pythagorean theorem. Okay, one of the best and probably the most productive strategies is to look out for right triangles. If you can find right triangles, then you can probably figure out some missing information. Okay, so Pythagorean theorem: a squared plus b squared equals c squared. All we need to know is how to plug it in, how to solve it, and then maybe we'll find our missing piece of information. Okay. Well, if we're treating this guy like our right triangle right there, okay, well, obviously plugging into Pythagorean theorem, you better get the hypotenuse right. Okay, so what kind of information would we want to plug in for C this time? It's the 13, exactly. Okay, so we'll make sure that we get the 13 in over there. Okay, now what are we missing? A or B, or does it matter? It doesn't matter, right? We're missing one or the other. It does not matter which is which. Okay, the hypotenuse is the only one that's important as far as getting it in the right place. Okay, now we're just going to solve for B. Okay, what's 12 squared? 144, exactly. B squared is unknown. What's 13 squared? Oh, everybody knew 12 squared. Nobody knows 13 squared, huh? It's 169. I have no idea what that sound was, but okay. Well, yeah, me too. Okay. Anyway, solve for B. Okay, so we got to get B by itself. So what's the first thing we're going to do here? Yeah, subtract that 144 to the other side. Whatever we do to one side, we have to do the other. B squared is, oops, getting ahead of myself there, 25. B squared is 25. We don't want B squared, we want just B. So how do you get the square off your B? Yep, square root. And whatever you do to one side, you do to the other. Okay, that is B. 25 is 5 times 5. That's your pair right there. Okay, there we go. B is 5. That's the answer to our question, right? No. Okay. Yeah, absolutely. Pay very close attention, especially on multi-step problems where you have to solve one thing so that you can solve another. Probably 2 out of every 3 questions you see on a multi-step question, this will be one of the answers. Okay, they're not trying to trick you. They're just seeing if you're paying attention. Did you solve the problem you were supposed to be solving yet, or did you quit one step too soon? Okay, so 5 will, in all likelihood, it'll be one of the answers on the test. Okay, it's just not the right answer. Okay, so we're on the doorstep of finding the answer here. We just have to finish it off. We need to plug into our area formula. Okay, we already said that the base was known at 12. We just discovered that our height was going to be 5. So our area is 60 square yards. Now, while we're here and thinking about it, what do you call this where you have a right triangle where all 3 of your values are whole numbers? Yikes, everybody needs to know this one. Okay, when you have a right triangle and all 3 side lengths end up being exactly whole numbers, this is called a Pythagorean triple. Okay, Pythagorean triple. You need to know that vocabulary. Okay, but anyway, there's one possibility of how this might work. Let's look at another question. This time we are finding the area of a parallelogram. So once again, we've got a diagram. It's nice if we have a diagram. Sometimes they don't provide them for us. This time they did. Okay, so again, the first and probably most important question is, do we have a formula that goes along with finding the area of a parallelogram? Yep, and once again, it is base times height, straight off of the formula chart. Okay, have a look into the diagram. This time, do we have the required information? Still no? Why not? Yeah, missing the height. Okay, what about a base? Do we even have a base? Yeah, you do. Okay. Anyway, so how about a base? We could call that 10 millimeters all the way across, and the height would be this guy perpendicular to it. But once again, we are missing the height, so we're going to have to figure out something to do to find it. Okay. What do you think? Well, we used Pythagorean theorem last time. What do you think about Pythagorean theorem this time? Will it work? Okay, to use Pythagorean theorem, you have to have 2 side lengths of triangle. Do you have them? Hmm, you do. Okay. All right. Do you have the hypotenuse? You've got the hypotenuse, 5. Okay. What about the legs? Obviously, the height is sitting right in there, and it's going to be one of the missing legs. Okay. Question is, what about this other leg? Yeah, exactly. They said that this is a parallelogram, so not only are opposite sets of sides parallel, but they're also congruent to each other. So if this side across the bottom down here is 10, that's going to force the side across the top to be 10, which means this value right there is how much? That's a 3, even though they didn't mark it. Okay, always be on the watch out for right triangles. We got lots of rules that can help us with them. Let's work through this one. What's 3 squared? 9. B squared is B squared, and 5 squared is 25. Okay. We would want to subtract the 9 away from our b's, which would put b squared at 16. Yeah, yeah, but we don't want b squared. We just want b, so we'll square root, square root. Yeah, 16 is 2 times 2 times 2 times 2, 4 2's. So 2 of them are going to join together. That's a 2. The other 2 are going to join together. That's a 2. When they come out, you got 2 times 2. That's your 4. Is this a Pythagorean triple? Yes, it is. This is the most basic Pythagorean triple, the 3, 4, 5 right triangle. Okay, so 4 is the answer, right? No. Okay, not the answer. I'd watch out for it. It may be an answer choice, but it is not the answer because we have not answered the question yet. All right, so what are going to be our base and our height in this case? 10 and 4, obviously 40 square millimeters. The actual calculation is not that difficult, but sometimes setting up the problem is. Okay. All right. Let's look at another one. one of the things you're going to notice about the area type questions is either they are going to provide you with a diagram or a problem. They may not ever give you a diagram, it's completely up to them, but they're going to present you with a problem that either does not give you very much information at all, or they're going to give you a problem that gives you an excessive amount of information. So they're going to make you figure out everything that you need to know, or they're going to make you sift through everything that they gave you in order to figure out which information is actually needed. So find the area of the following rhombus. Okay, well, first question again, do we have a formula for finding the area of a rhombus? Okay, area equals base times height. Still a parallelogram, no matter which of the kinds of parallelograms they want to call it. Okay, so have a look into this diagram. Do we have the information that is needed to plug into the area formula? We do? Okay, we got some disagreement going on in the classroom. Do you have something you can call a base? Yes. Okay. We do have a base. Okay, how big is your base? It's 8. How do you know it's going to be 8? Because if your base and your height need to be perpendicular to each other, then that puts them in these locations here. Okay, how do you know that this location across the top is going to be 8 kilometers? Because the other one's 8 kilometers, right? They said it's a rhombus. A rhombus is equilateral. So if one side is 8 kilometers, then they are all 8 kilometers. What about the height? Okay, height's not provided for us. Can we find it? Yeah. This side over here, is it not 8 kilometers also because it's a rhombus? Yeah, here we go. A squared plus b squared equals c squared. Okay, hypotenuse in this case is 8. We have a leg at 2 and another unknown leg. 2 squared, 4. 8 squared, 64. Subtract 4 from both sides. B is 60. Okay. We don't want b squared, we just want b, so we'll take the square root of both sides. All right, well, 60 is not a perfect square. Okay, but 60 is, let's see, 2 times 30. 30 is 2 times 15. 15 is 3 times 5. Okay, got any pairs in there? Yeah, I got a pair of 2s. We can get a pair of 2s out. And the 3 and the 5 are stuck, so we'll recombine them. 2 square root of 15 would be the most accurate answer that we could come up with in this case. Now keep in mind, on tax or star, you're going to get answer choices that are in terms of decimal points. So probably we would be in our calculator right here at square root of 60, get a decimal point from there, and continue on with the calculation. If it's ACT or SAT, okay, you're going to leave it as 2 square root of 15 and then carry on with the calculation. Okay, so whether you do your calculator at square root of 60, which is somewhere in the ballpark of 7.6, 7.7, something like that, or whether you're going on with SAT or ACT using 2 square root of 15, neither one of those is the actual answer, right? Because the question is, what's the area? Okay, so well, we just figured out that guy. Okay, so up here, we've got a base of 8, and we've got a height of 2 root 15. Okay. Now remember, by multiplication, when it comes down to combining whole numbers and radicals, yeah, whole numbers want to get other whole numbers, radicals want to get other radicals. So the 8 and the 2 will combine to make 16, and the square root of 15 doesn't have anybody to combine with, so it's just kind of hanging on for the ride. Okay, so it's whatever 16 times the square root of 15 square kilometers is, that's your answer. And again, if this had been, if this is tax or star, we'll take this decimal point, square root of 60, multiply by 8, and we'll get a decimal point for our answer. Okay. But there's just no guarantee on Pythagorean theorem that you don't end up with radicals or decimal points, because that's kind of the nature of Pythagorean theorem. It's got all these square guys inside of here. Square guys are going to mean square roots, and square roots are going to bring square roots into the problem. There's just no getting around it. Okay, but this one is definitely not a Pythagorean triple because we did not get whole numbers. Okay. Let's look at a different type of problem. Okay, so find the area of the following triangle. All right, do we have a formula that tells us about the area of triangles? Yep, 1/2 times base times height. That formula makes perfect sense if you get to thinking about it, because a triangle is half of a rectangle. The rectangle's formula is base times height, so half of it. Okay, so 1/2 times base times height. That's on the formula chart for you as well. Okay, now have a look into your diagram and see, do we have the necessary base and height information? Do you have some of it? I don't see any of it. Okay, when you look in there, I don't see base or height. Okay, so if we wanted to say like, hey, this is base and that's height, then okay, neither one of them are there. Yeah. Okay, so let's see. We've been relying on Pythagorean theorem. Okay, so if that's the case, let's see what we can do here. We could plug in. What do we know? We know 7 for the hypotenuse. And what's the problem now? Yeah, you still got 2 variables stuck in there, and we don't have either one of those values. Pythagorean theorem can't help us unless we can provide it with 2 of the side lengths, which we don't. Yeah, also keep in mind, guys, Pythagorean theorem is not the only rule that we have that operates inside of right triangles. Okay, as a matter of fact, SOHCAHTOA is a more powerful rule. But the thing is with SOHCAHTOA, if you want to solve for a missing side length, which is what we're having to do here, then you had better know an acute angle measurement. Okay, if you've got an acute angle measurement, then we can probably use SOHCAHTOA. Okay, a little crash course review here. Remember SOHCAHTOA, it's 3 little groups of 3 letters. We've got sine and cosine and tangent, and the sine and cosine and tangent ratios operate with these different side uh, ratios that are in there. So let's have a look. We got an acute angle. That's our theta. Okay, so we're going to use that 25-degree guy right there as theta. Let's figure these guys out. I'm just going to pick on B, the base, okay, since it's the first value that I see in the formula. Okay, so I'm looking for that guy. What's the name of that particular side? This, this side link has a name. All 3 of these sides have a name when it comes down to SOHCAHTOA. How about this? What's this guy? That's the hypotenuse. What's this guy over here? Opposite. So what's this guy next to him? Adjacent. So we need the adjacent side. We do have the hypotenuse. So we have a look into SOHCAHTOA and go, okay, SOHCAHTOA, what ratio calls on adjacent and hypotenuse at the same time? Okay, so adjacent and hypotenuse sitting right there looks like cosine. Okay, so let's set it up. Cosine. Cosine of what? Cosine of theta. Okay, so the angle measurement, 25 degrees. Okay, the trig functions will always equal the ratio that comes after them in SOHCAHTOA. Okay, numerator is the first thing listed, adjacent. Denominator is the next thing listed, hypotenuse. Adjacent over hypotenuse. Okay, so what's our adjacent? B, and hypotenuse, 7. There we go. There's the equation. Okay, we want to isolate B. Exactly. What's happening to 7 right now? It's being divided. So if we want to move it, we have to do the opposite of division, which is multiplication. So we'll multiply by 7. And of course, whatever we do to one side, we must also do to the other side. Okay, that takes care of that on that side. Now we will go to our calculator to figure out what is the deal with 7 times cosine of 25 degrees. So I'm going to pull up my calculator here. Okay. Always keep in mind that when you are doing trigonometric functions, okay, double check the mode of your calculator. If the person that was using your calculator was not very smart, then some of the things may be adjusted around. We want to be in degree mode because our measurement is in degrees. Okay, our angle measurement's in degrees, so our calculator needs to know we are in degrees. Okay, so my calculator is set up well. I'm going to go ahead and get out of that. And now I just ask, what is 7 cosine of 25? And the calculator knows. Okay. It is in the ballpark of 6.34. I would go ahead and I'd at least use a couple of decimal points at this point. The further you round off now, when you plug into your formula later on, the further you round off now, the further your answer is going to be away from the right answer. Okay, so I wouldn't round any further down than a couple of decimal points on this. Okay, now is this our answer? No, crud. All right. Well, that's that. Okay, now what? Yeah. Yeah. Could we take B from here, plug it in there, and finish off Pythagorean theorem from there? Sure could. Okay. Could we use SOHCAHTOA again to find out what's going on with the height over there? Sure could. Either way, since we got SOHCAHTOA out and running here, I'm going to go ahead and finish the problem using trigonometry. Okay. To find H, what are we looking at? Opposite and hypotenuse. Now, could I use B? Okay, now that I know what B is, could I use the adjacent side in order to help me solve for the opposite side? Sure. I wouldn't do that though, because what happens if you missed B right here? Yeah, if you miss B and then use that value to plug in to help you find H, then you automatically missed H. Okay, so I would stick with values that you know for a fact are good values. Okay, so but anyway, H is opposite, 7 is hypotenuse. So look at your trig functions and go, all right, do I have an opposite and hypotenuse somewhere? Yeah, the sine function does that. So I'd go, all right, sine of 25 degrees equals opposite over hypotenuse. Okay, again, that 7 is being divided in there, so to move it, we have to multiply it out. Okay, there's that. And once again, we would go to our calculator to help us understand what is 7 sine 25. You don't have to worry about the setup of your calculator every time. Once you get it changed to degree mode, it should stay there until some fool messes with it. Okay, but 7 sine 25 is in the ballpark of 2.96. Okay, so H is about 2.96. Now that's our answer, right? No, still not done. Okay, this is a three-step problem. We had to solve for B, we had to solve for H so that we could come back to the area formula and finally get an area. So let's have a look here. Yeah, we already did B. It's over here. Well, yeah, the formula needed both B and H, so we solved for both of them. Okay, so the formula says 1/2. There's our 1/2. Formula says multiply by B. Okay, I rounded it to 6.34. Okay, and the formula says height, and we had that rounded at 2.96. Okay, and we get an area. I got something in the area in the ballpark of 9.38 square feet. And again, I would not round it any further down than about 2 decimal points. Okay, the more you round earlier in the problem, the further this gets away from the right answer. In fact, if you had used all of these decimal points, 6.344154509 and 2.958327832, if you use all those decimal points rather than rounding it off to 6.34 and 2.96, you'd have a different answer right here. Okay, it wouldn't be off by a whole lot, but it is off. Okay, so don't round too much too fast. Okay, so always keep your eyes open for the possibility of SOHCAHTOA. You never know where some of these things are going to show up. Now, we absolutely need to take a look at a square. Okay, squares are their own interesting little animals. and they work a little bit differently than some of the other problems sometimes. Okay, well, just like any other problem, do we have a formula that goes along with area of a square? Yeah. What's its formula? Side squared. It's base times height, just like any other parallelogram. Okay, but more specifically, since the base and the height are going to be the same value twice, typically we just say whatever the side is squared. Okay, well, have a look at your figure. Do you have this information? No, you don't. Okay, any thoughts on how to get it? SOHCAHTOA? Okay, now in order to use trigonometry like SOHCAHTOA, you have to have an acute angle to work from. Okay, well, we know we have squares, so we know we have right angles running all over the interior. There, and there. Okay, what about an acute angle? What about that diagonal cutting through there? Yeah, that's one of the properties of a parallelogram, is that the diagonals, when they come across like that, it is going to bisect the angles that are there. Okay, so that means this angle and this angle, this angle and this angle, they are all going to end up being half of 90 each. Okay, so we'll end up with a bunch of 45s. Could we use those 45s as an acute angle, set up SOHCAHTOA, and help us solve for a side length? Absolutely. And I am not going to do that. Okay. Not going to do that because there is an easier way out here. One of the properties of a square is that it has perpendicular diagonals. We have a special little formula that deals with perpendicular diagonals. Remember that formula? There you go. We got a different formula. 1/2 times diagonal 1 times diagonal 2. Okay, if you have all the exterior information for a figure that's got perpendicular diagonals, like a square or a rhombus or a kite, if you've got the exterior information, by all means use those formulas. But if what you have is interior information, you might want to pick a formula that talks about interior information, like this one does. Okay, because in this case, we already have one of the diagonals at 6 units. Okay, what do you think about the other diagonal? Is it 6 also? Yes, it is. A rectangle has congruent diagonals. The overall length of one diagonal is going to equal the overall length of another diagonal, and a square is a rectangle. So that's going to force the other diagonal to be 6 as well. 6 times 6 is 36, and half of that is 18 square centimeters. Now, could you have done SOHCAHTOA, figured out what's going on with the outside side lengths, and then plugged in here for side squared? Absolutely, you could. And if you don't make any mistakes, you will get to the same answer that I just got to. Okay, but if you kind of keep your head up and know all of your formulas, then you'll find that some of the formulas are easier to work with in certain instances than other formulas might have been. Okay? All right. Want to have a look at this one. This is one of the test writer's favorite shapes, and I've kind of warned you about this one throughout the year. It is the isosceles triangle. I'm sorry, isosceles trapezoid, not triangle. Okay, the isosceles trapezoid. A lot of times on the isosceles trapezoids, they don't actually draw the picture for you. They typically describe it in plain language. If you want to see a diagram of it, then you have to draw the diagram for yourself. Okay, but in this case, we have the diagram provided for us. Okay. All right, just like any other problem, do we have a formula that goes along with the area of a trapezoid? Sure do. What's that formula say? 1/2 times the sum of the bases times the height. Okay. I'll take a quick glance into the problem. Do we have all of the required information? Almost. Almost. Something's missing. What do we need? Height. And a lot of times when they do pick on the trapezoid, the height will be missing. Okay, and in this particular case, it's not even drawn in the diagram, but I think everybody could probably figure out themselves that, you know what, hey, we could put the thing right there, or we could put it right there, or we could really put it anywhere running along in between those two bases. Okay. All right, now we need a strategy for how we're going to figure out this height measurement. What do you think? And then there was silence. Okay, well, let's just think of it like this. We got two pretty sturdy rules we can lean on. We got SOHCAHTOA, we've got Pythagorean theorem. We know that SOHCAHTOA is going to require us to have an acute angle to work from. I do not see an acute angle. Well, I see acute angles, but I don't see how we can come up with the measurements of any of them. Okay, we're missing some stuff. Okay, so let's just think along the lines of Pythagorean theorem is going to have to be the deal if we cannot get SOHCAHTOA to work. Okay, well, you can see the triangles in there. Okay, so we've got 5 as a hypotenuse. Okay. Height is obviously going to be unknown, so we're going to need to be able to figure out the other leg of the triangle if we're going to get this. Okay, any thoughts on finding the other legs? Yep. Here's the answer. Okay, part of the reason they pick on isosceles triangles. Okay, if the trapezoid is isosceles. Okay, you remember the property of triangles where it basically said if you have two sides that are congruent, what does it mean about the angles that are across from them? They're going to have to be congruent also. The same type of property applies across an isosceles trapezoid. So that's going to force these guys to be congruent. Now we've got two angles in a triangle that are congruent to two angles from another triangle. That's going to force the last set of angles to be congruent. It's going to force these triangles to be congruent. So what that means is when all the talk gets done, this side right there and this side right there are going to have to be congruent because of that word, isosceles. Okay, how does that help us? Okay, if it's 16 miles all the way across the larger base of this trapezoid, how can we figure out what's going on with these little double tick marks? 3 and 3. How do you know this? If it's 10 units across up there in between those two heights, then it's 10 units across, or 10 miles across there in between those two heights. And if these have to be equal, then as Josue told us a moment ago, there should be 3 units shared equally with those guys. Okay. Now some people said this a few minutes ago, and so I've kind of been over explaining it. But does anybody know what the height is going to be? It's a 4. That's right, because we've got this is the basic 3, 4, 5 Pythagorean triple. Okay, so it's going to be a 4. Let's go to the formula and see if we can't figure this mess out. 1/2 is 1/2. It's part of the formula. Do you know base 1 and base 2? Yeah. Does not matter which one is which. Simply get them plugged in. And height is 4. And even if you didn't remember the whole Pythagorean triple thing, you could still plug into the Pythagorean theorem over here and solve for it. Okay. Anyway, it's all done but the number crunching here. Where do you have to begin on this math? Inside the parentheses, absolutely. If you don't, you probably just missed it. 10 and 16 is 26. Half of 26 is 13, and 13 times 4 is 52 square miles. And there you go. Guys, we could probably literally spend just about every day for 2 solid weeks doing nothing but questions like this, and we would probably never cover all of the different situations that they could possibly come up with. Okay, but the best basic strategy is whenever you're missing information, look for some right triangles. If we can find some right triangles to set up in the problem, then we can probably solve for whatever it is that we're missing, Then we can plug into the area formula. And of course, the basic rule, as you saw over and over again, was never give up on the problem until you actually answer the question that they ask. Okay, especially on these multi-step problems where you have to solve for one thing in order to solve for another. Easy to quit too early, and they will sometimes provide those that step one answer for you on the test, make it easy for you to miss it. Okay, so be sure you don't do that.